Good day, students. In this group, we're going to go over how to graph angles and also specify where what quadrant terminal side is on. Okay, so everybody write down the title of this lesson. Angles and radian measure. Angles and radian measure. Okay, let's start off by defining what an angle is, and then we're going to take a look at what the graph looks like. So write this down. Angle, this is the definition. Angle. This is the inclination of one ray known as the terminal side from another ray known as the initial side. Okay, so that's the definition of basically what an angle is. Alright, so what does this look like graphically? Let's take a look at what an angle looks like. I know you've come across this in geometry and other math classes. Let's say we have a protractor starting from 0 degrees. What if I move this angle up a few degrees, let's say 42 degrees? Let's extract that. Take this out of there. What I've just created is an angle. Okay, the inclination between this ray, this is known as the terminal side, and this is known as the initial side. Okay, the inclination between these two is known as the angle. So this 42 degrees is a measure of the angle in degrees. Okay, so that's basically what an angle is. All right. Okay, moving along, let's consider some examples that really solidify our understanding of how to graph angles relative to the initial side. So let's write it down. Write down examples. Alright, so this is instruction that we're going to be using for the examples. For the given angle, sketch the terminal side and specify what quadrant that lies in. Okay, number one, let's try 99 degrees. Okay, alright, so let's go ahead and graph this, sketch it, and then see what the quadrant it falls in. Okay, let's see. So for every problem I give you, you have to draw a new coordinate system. Okay, so let's draw a new coordinate system right here, like that. This is your x, this is your y. Now remember that every degree, this is going up is positive, up and about is positive, and then going down and around is negative. Alright? Now, another thing to keep in mind is that every quarter of a circle is a right angle. Okay, so every quarter of a circle is 90. So this is 90, 90, 90. Okay, so let's label and see where 99 is. So this is 0 degrees. Since it's positive, we're going to go up, right? So if we go up, up here is 90 degrees. Do we keep going around or do we stop? This is smaller, so we keep on going. Another quarter circle is 90 plus 90, which is 180. Keep going or stop? We already went too far, so we're going to backtrack. 99 is going to be somewhere close to 90, so it's going to be somewhere right here. Okay? So, from here to here, that is 99, that's 99 degrees, alright? This is the terminal side. What quadrants does this terminal side reside? Remember, this is quadrant 1, this is quadrant 2, 3, 4. So since it stops in the second quadrant, it's going to be in quadrant 2. Okay? This ray right here, this is known as the terminal side, and that's 99 degrees. Alright, let's try another example. Number 2. Let's look at 340 degrees. 340 degrees. Alright, so make a coordinate system. Starting from 0 degrees. Are we going to go up or down? Since this is positive, we're going to go up, right? Remember, going up is positive. So we're going to go up. Quarter circle is 90. Too small, keep going. Go another quarter circle is 90 plus 90, which is 180. Too small, keep going. Quarter of a circle is 3 90s, which is 270. Too small, keep going. Another 4 quarters is 4 times 90, which is 360 degrees. Too far, we're going to backtrack. It's somewhere here. I think it's closer to 360 than it is to 270. This is just a sketch, okay? It doesn't have to be perfect. Alright, let's draw the angle. The direction of the rotation was like this. Down. Alright, so this right here, this angular rotation is 340 degrees. What quadrant is this? This is 1, 2, 3, 4. So our terminal side is in quadrant 4. Quadrant 4. Okay? Alright, let's move on to 3. Move on to 3. Negative 45 degrees. Alright, so let's try, we're doing a negative angle this time. So we're going to start out by making a coordinate system like this. So 0 degrees up or down. Since the angle is negative, remember, downward rotation, or this is also known as the clockwise rotation, is negative. Right? Interesting, our clock is going in the negative direction. So basically going down in the direction of the clock is negative, so we're going to go down. Whatever circle, this is negative 90. Keep on going. Oh no, we already went too far, so we're going to stop. And 45 degrees is going to be right in the center, right here. Alright, what was the direction of our rotation? Downwards. Right there. Like this. So this angle is negative 45 degrees. And it's in quadrant 4. For the 1, 2, 3, 4. Quadrant 4. Okay? So quadrant 4. Quadrant IV. Okay? Alright, now let's take a look at another example. Example number 4. What if we have negative 180 degrees? Okay? So how do we do this? Make a coordinate system. Probably symmetrical. I'm going to try to make this a little bit symmetric. Alright, so starting from 0 degrees, up or down, since this is negative, we're going to go down, right? So that's a negative direction. So this is negative 90. Too small. Backtrack a little bit, counterclockwise direction. Clockwise direction, negative 180, stop. You notice this is where our terminal side is. Our terminal side is going to overlap on the negative x-axis, okay? So you can put the arrow there to make it obvious. This is our rotation right here. Bam. This is negative 180. Now what quadrant are you on? Again, the third quadrant or the second quadrant? You're sitting on the fence, so you basically do not have a quadrantal assignment. So you're going to just simply write negative. You're on the negative, oh snap, I can erase it. Negative x-axis. Okay, so that's how you have it. Alright, let's try one more example before we start on the classwork for today. Example number 5. 434 degrees. Okay? Alright, this is a positive angle. Let's see where the sketch is going to be at. Okay, so I'll make my coordinate system. Starting from 0. So this is positive, we're going to go up, right? So 0 up is 90. Keep on going or stop. Another 90 is 180. Keep on going. Too small. 270. That's 3 rights. Keep on going. 360. Oh, that's not even sufficient. Keep on going. You can wrap around again. 360. We're going to add another 90. What's 360 plus 90? 360 plus 90 is 450 degrees. So 450. Oh, too big. So stop. We're going to backtrack. It's going to be somewhere here, right? So this is where angle is going to be. It's going to be somewhere over here. Alright, so how do we graph our spiral to get to this point? Start from 0, went round to 90, 180, 270, 360, bam, right there. See that? That is 434 degrees. What quadrant is the sun? It's in quadrant 1. Okay, so that's that for the first part of the notes. Alright, welcome back, students. We're going to do some examples using the formula we just went over, the conversion factor. So let's just write down the titles of the examples we're going to do. Converting between radians and degrees. Okay, we're going to be combating back and forth between radians and degrees. Okay, so let's take a look at the examples. Example 1. Change or convert, change 200 degrees to radians in terms of pi. Okay. Alright, so let's do this. So to do this, we're going to write down 200 degrees. This is what we're going to change. And we want to multiply it by the conversion factor, okay? We have two choices to pick from. The conversion factors are pi over 180. Pi over 180 is the same thing as unity, same thing as 1, pi over 180. And, or what? 180 degrees or 180 degrees over pi. Now these two numbers are exactly the same thing because they're both 1, okay, and they're identical top and bottom. So the question is, which one do we pick? The first one or the second one to do this conversion? Since we have degree on the top and want the degree cancelled, it would be wise for us to pick this one right here, right? Because this one has a degree on the bottom. So if I put it here, pi over 180 degrees, what happens? Notice as degree top and bottom, the degrees cancel, and we are left with pi radians. Okay, so this degree and this degree cancel, and then we can multiply it across. So it becomes 200 pi over 180. The zeros can be cancelled out as a result of dividing by 10. What goes into 20? The biggest number that goes into 20 and 18 is 2. So 2, we divide both of them by 2. 2 goes here 10 times, and 2 goes here 9 times. Your final answer is 10 pi over 9. So what does this mean? This means that 10 pi over 9 radians is the same thing as 200 degrees. Okay? That's what our answer means. Alright, example 2. Let's take a look at another example. Let's convert change 2 pi over 3 into degree measure. Okay, so this pi right here is an indication that we're dealing with a radian measure, right? So Which conversion factor will help me get rid of this pi radians? Is it the one with 180 on the bottom or the one with pi on the bottom? Since pi is on the top here and I want it cancelled out, then I need to pick the one with pi on the bottom, right? So we're going to write 2 pi over 3, 2 pi over 3. We're going to multiply it by a conversion factor that will change it from radians to degrees. So option, what are we picking? We're selecting option 2 because it has pi on the bottom. So we're going to times it by 180 over pi. Does this change the problem? No, because 180 over pi is the same thing as 1, and 1 is a multiplicative identity. Alright? So, notice the pi's cancel out. That is exactly what we want, and we have degrees left. We multiply it out, it becomes 360 degrees over 3. 3 goes into 360, 120 times 120 degrees is your final answer. Okay? Alright, so we're going to go ahead and try some examples. Thanks for paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure.